Hi everybody, and welcome to part 1 of 6000, a series on the Data Genesis 3.5 system. I'll call it DG35 for short. Um, the goal of this is really to kind of teach everybody about how DG35 works, how it gives us a little bit faster way of development, and how we can take that knowledge that has been learned over the years and put it into a framework that we can scale well at a secure way, based on query injection and knowledge of the SQL Server 2008 R2 system and some of the hacks and tricks that we've used in order to make sure queries stay fast. And what I wanted to do is first kind of go over this, talk a little bit about the system, and find out how exactly this applies to the different modules and how it applies to our web front end, as well as our web API, and our existing SPNet systems. First, I mean, the goal of when we first designed this system was to create a faster system to develop software. We found that most everything we did took about 80% of setup time for just typing fields in onto the screen, or trying to figure out how to where all the relations were, and we put those into object models, or write store procedures in order to return data the proper way. And just these simple CRUD operations were really taking about 80% of the time, and of course, human error, was involved too as well, adding bugs and other things to the system. So we were, constantly challenged to fix these small bugs of simple updates weren't working, or an insert was double inserting, or the delete didn't work. So they would all have to be tested for every single module we had. And going into more of a dynamic generation based off of, say, some metadata, we were able to eliminate the need for checking all of those statements to make sure that they were coded properly. And this was really done for originally done in DG2, which was a very loose system, but it was very rigid in the sense of that you had complete access to the query system, but you still had this document and dictionary system that was very cumbersome to maintain. So as time went on and we evolved the software, we created a software that reduced the amount of metadata that we had, but we still had to have some in order to define what kind of information we're pulling from these tables. So we created a set of front-end tools that were used for the management of that data, and subsequently the creation and the updating of the information. Whenever we made database changes, we could use these tools in order to do that for us, instead of having to have intimate knowledge of the database. In addition to, is we found that security needed to be tested for every single module we designed. This security was cumbersome because of the size and the requirements of how the security was run. Became more and more complex with the larger systems that we're designing, and our customers were demanding more for how much their customers could see, and how do we guarantee that one customer can't see another customer's data. This is a problem because of as our staff grew, we had a problem relaying those security rules as they become more and more complex to every one of the members on the team. And without intimate knowledge of how that security ran, we found that developers would just ignore it and say, no problem, I don't need to use security. I'll select it because I'm getting my task done. I'm not really thinking about how somebody could hack into the system. So how this works is through this kind of, if you ever heard of these graph databases, and how they work, and graph mathematics, graph theory, it's kind of like that, but we do it through kind of a denormalization of data through triggers. And as you know, if you've ever worked in SQL, or obviously have worked in hierarchical information on C# or any other programming language for that part, it becomes exponentially more and more and more complex as you start going down the chain. To be able to check millions of rows of data against, say, one or two users and their roles, that could be billions of checks done for each one of the rows that are going through, to make sure that, or each one of the queries being run, in order to return that information or filter the information out for the user, depending on how large the system is. So instead, we created this matrix of different combinations or a hierarchy of that flattened out, and then it's denormalized through a set of triggers in order to maintain that data in I guess a concurrency of that data, for the system. So we take that, we join against this table, and then magically the data is filtered out. And I'll get more into that later, but ultimately it's really based on the roles, what part of the user that role is, or the part of the profile is that role is assigned to. Say, for instance, of a user in this division here, if they had a specific role, those permissions attached to the role would then go through from its parent to its children. It would not go backwards or laterally through its siblings. It would just go from its current profile down to its child profiles. Same goes with a user could be associated with multiples. So let's say if a user was associated with this branch and they were able to, I don't know, read the name and address of their party contacts, but here they're able to read and write party contacts. The system would check for that without any programmer change. It's just a matter of get me the data and save the data, and that's all the programmer really has to worry about. So what's nice about this as well is that we have a standards adoption. The standards adoption really allows us to grow the team without having to worry about who on the team is programming what and how they're programming it. Everybody kind of understands what these systems do. They understand the security, they understand all of the dictionary, they understand how we make use of the data sets, in this current version, and they're also very familiar with how these tools work. So that being said, we again reduce the amount of time it takes to onboard any given person because of the team's knowledge of the existing framework. The framework is built off of C#. It's built off of older data sets. We didn't move into Entity Framework yet because this is just a port before the Entity Framework really existed. And but still, the technology is strong and it works. It works well. It's very, very fast, and we have a lot of staff on hand with intimate knowledge of how that works.